Good day, everyone. Raheem Kayode, my name. I'm here to present my project, Therapeutic Capability of Selected Mutant Plant Bioactive Constituents against the mutant ovarian TP53 gene using computational approach. Rightly being said, the mutant TP53 gene has been the source of this cause of ovarian cancer. So, as it has been known in the time past, it's been a druggable target. So, that would lead us to able to uh, develop some plants that are able to restore the functionality of this mutant TP53 gene. Ovarian cancer is the most fatal genetic malignancy due to the lack of early symptom presentation and subsequent sampling of the late stage, and evidence from various literature are revealed that mutant TP53 gene are highly associated with the epithelial ovarian cancer. So small compounds that can restore TP53 functionality have been what the interest of what we did. So the objective of this research was to identify a potential bioactive compounds that can plant that can restore the functionality of mutant TP53 gene in ovarian cancer. So rightly being said, we employ the skills of computational analysis to run this in silico analysis where we get the sequence analysis of this mutant TP53 gene. We can work on work with the particular mutant sequence we retrieve, and we are able to do a modeling of this because reason why we did that was because the lack of this structural mutant gene was not available. So we have to do modeling, and with that, we have to do the structural refinement, the protein validation also. So the natural compounds were being retrieved from 7 plants that we are going to retrieve using, we got downloaded from the SDF file of this ligands, and we did ligand preparation, which lead us to do a molecular docking and to check for their connecting analysis, and also to ascertain our compound to check the activities. We did the extensional functionality theory calculation. So to the result side now, score on there, this two graph is trying to show the validation of a model using a poster. So now we check correctly here, the circle points, this region is show that model mutant trajectory fall at the region that has a 2 to 5 Armstrong, and this side is a graph having the Z score, and is the residues of this mutant trajectory fall at the probable region. So the scores now, we did molecular docking analysis where we check where this compound we retrieve to dock it at the binding site of this mutant 53. Out of the compounds, we're able to discover the compound that have a higher binding affinity, and that is being stated there. That is this, it will be taken as a higher binding affinity compared to the reference drug. That's the drug we treat from the FDA approved drug, because most of our compound we treat has a higher binding affinity compared to this reference drug that we had as a list. So to able to ascertain our result, to check the toxicity and the admit property of this compound, so able to correct other analysis, checking using this principle of lipid rule of 5 so we need to screen out compounds that are able to have a good like facility, checking their stability, checking their solubility. So out of the 15 compound, we able to come down to 4 of it. We have listed there. So firstly, the second showed that as what the molecular weight was a bit higher than the standard one. Than what we're saying as this, that the lipidity of this compound was still below the lipidity log of 5, and the iodine point donor was below 1. So these are the 4 compounds show a better compound. They have a less toxicity. So this side is the binding interaction at the pocket side of the protein. So the binding interaction of the protein at the amino side of this. So this green side, it was showing the hydrogen covalent bond at the active side of the protein. So to check for their stability of this compound and the activities I wish to carry out using this functional theory. So out of these four compounds, discovered that the irinotecan was the most stable one because according to the principle said the bind gap between these two HOMO, if it's less, that means it's compound more stable. So showing that out of these four compounds, irinotecan was the most stable compound, and then hydroxy capacitecan was less reactive, was the most reactive compounds compared to the reference drug. Yeah. So so now out of this compound, they portray a good favorable binding model than the reference compounds and interact with the essential amino acid, and they contribute with a modulation of drug targets for a better selectivity. The lead compound exhibit a excellent pharmacokinetic properties and let us compare with the standard drug. And the calculation reveals anatomic portion of this compound, either to donate or accept electron through HOMO and LUMO band gap and global descriptor. So the study always cover that out of these four compounds retrieved from these plants are found in have shown a good novel modulators of this mutant T53, and this study we only considered a single type of mutant among the other mutants associated with ovarian cancer. So we suggest that further study are encouraged to be done in future to identify other mutant. So we encourage further weight analysis to ascertain this for compound, because the in silico analysis are able to ascertain that this compound can be a good novel to modulate the 52 to restore its functionality. Thank you everyone for listening.